In this session, we will see about an binary tree traversal. So in the last session, we were covering about an how can we uh, create an binary tree using a linked list. So we have seen what is meant by binary tree. Binary tree means what? Every node can have a maximum of 2 child, okay, and minimum of 0. So it can be a single node also, or it can have a 1 child or maximum of 2 child. So now we will see how can we visit all the nodes in the tree. That is called traversal. So the traversal can be performed by using three types, either in-order or pre-order or post-order. So we will see one by one. It's an in-order. So in-order means what? At first, it will traverse the left node and then root node and then right node. So always it will go to the left node first, visit it, and then root node and then right node. Okay. So now here in this example, how do you do? At first, traverse to the left node, so B, and then A will be visited, and then C will be visited. Okay. So now traverse left node, B. So for B, there is no left child. There is no left child. So since there is no left child, then next one is root. So root is B. So for B, is there any right child? No right child. So nothing. So to come back over here. So for B, A order for A left is finished. Our next is root A. And A right child is C. For C, does it have any left child or right child? No. So it is a B, A, and C. Okay. This is an in order traversal. So the algorithm is while tree is not equal to null, so it will go to the in order tree of left, and then write the tree of data. And then it goes to the in order tree of right. Once again, the same function will be called once again, and again. Okay. So now see here, this is example. So in order tree of left. So for A, it's a left tree. It's a left tree. So once again, what happens over here? The same function calls once again in order tree of left. So the B becomes root node. The tree B becomes root now. So now what happens over here? The left side of B is D, G, and H. Once again, the same function will be called G. Okay. So once again, is there any left child is there or not? Okay. So now what happens over here? The result G. Because why? The result is null. The left child is 0. So it will write the tree of data. It will write the tree of data. And then it goes for the right side. There is no right side. There is no right child. So then once right child is not there, then for G left is finished. For D the left is finished. It goes to the root. Always the in order means what? Left, root, right. So left is over. Now root. D is over. And then for D, right side. H and L. H and L. The same function we call once again. So now what happens over here? For the H, there is no left. It's null. So then comes back over here. And then once left child is not there, I will write the data of an root. So H is written over here. And then once again, right side. For the right child, there is no left child. So it comes back to the root. Write the data. And then goes to the right side. There is nothing. So now what happens over here? So G, D, H, L is over. Left side of B is over. It's a recursive function. So the B of left is completed. So then what happens over here? Once B of left is completed, it goes to the B. It goes to the B, the root. The tree of data B. So for B is written, then right side of B, we have an E. For E, there is no left child, there is no right child. So null. It will write only the root, E. So then for A of left child of A is completed, fully completed. So once A of left child is fully completed, it goes back to the root. So A. Okay. So once root is completed, then I'll go to right side. I'll go to the right side fully. C, F, I, J, K. So here, next is C. For C, is there any left child? No. For C, is there any left child? No. So since for there is no child for C, left child of C is not there. So then I'll go to the root node, C. So C is written over in the output side. Then right side of C is Fijk. So then what happens over here? Once again, for F, the left is I. For I, there is no left child. Only root node is there. So I've written the I. I've written the I. So then left child of F is completed. I is completed. Then next is root. That's a F. F is written on the output side. Once F is done, root is done, left, root is done, then I'll go for right side. Right side is J and K. So for J and K, left child of J is K. So K is written over there. And once left child of K, J is completed, next is root J. J is written on the output side. So there is no right child of J. So this is called an in-order traversal. So this in-order traversal means what? At first left, root, right. Visit the left. So for A, B is the left. For B, D is the left. For D, G is the left. Recursive function, calling same function again and again, again and again, again and again. Okay, until null comes. Until null comes. So when the null comes, the G of left is null, G of right is null. So until G of left is null comes, it will keep on calling the same function. So once G of left is null comes, that means that there is no left child. I can go for the root. So I will write the tree of data. Then I'll go for right side of the node, null. So then once the left child of D is completed, I'll go to the root, D. And then I'll go for right side of the root. So calling same function again and again, we can perform the in-order traversal. Next is pre-order traversal. So in order means what? Root will be in center. Pre-order means what? I will visit the root first and then I'll go for the left child and right child. Okay, in order means left, root, right. Pre-order means what? Root, left, right. So now here visit root node, left node and right node. So root node, A is done. And then I'll go and visit the B left. So now this is subtree. For subtree B, is there any subtree of B? No. Is there any child of B? No. Okay, so B is done. And then I'll come to the right side. In the right subtree. In the right subtree, C is the root node. For C, is there any left child or right child? No. C is there. So we will see this function. This is algorithm for the pre-order. It's simple. The algorithm is simple. Where in the in-order, the right of tree of data was in the third line. In the pre-order, it goes to second line. You can see here, the right of tree of data is in the third line, in the in-order. And then in the pre-order, it goes to the second line. So now what happens over here? At first, I will write the root node and then I'll go for the left child and then right child. So here A is the root node. So A is written over there. Then I'll go to the subtree. In the subtree, which is a root node, once again the same function call has been called. So B is the root node, right? So B is written over here. And then I'll call the subtree DGHL. So in this, which one is root node? D is the root node. So right tree of data. So D. So for this, which one is left subtree? G is the left subtree. Okay, so G is the root node. So G is written. For G, does have any left or right? No, since it's null. This comes back to the D function. It goes to the right side. It goes to the right side, H and L. So for H and L, which is a root node, H is the root node. H is done. For H, is there any left child? No. Then goes to right child. For right side, root is the L. So L is written over there. For L, is there any left or right? No. So it goes back to the B. B of B is already, root is already done. Left of B is fully completed. It goes to the right side of B. So E. E is the root node. So E is the root node. And then E, does E have any left child or right child? No. So A is for A root is completed and left child of A is completely done. Now it goes to right side of A. So right side of A. So for right side of A, this is subtree. In this subtree, which one is root node? C is the root node. So C is the root node. Does C have any left child? No. So it goes to the right side of C. F, I, J, K. Okay, so F is the root node. So F completed. Okay, does F have the left child? Yes. This is subtree. So this is the subtree. I is the root node. So I is done. I is comes in the output side. Once I comes, does I have the left child, right child? No. So F, the left side of F is completely done. It goes to right side. In the right side, the root node is J. J is done. Once the root node is done, it goes to left child, K. And right child of J is nothing. So this is the pre-order traversal. This is the pre-order traversal. Okay, where we will visit the root node first, and then left child, and then right child. In the post order, what happens over here? Then left, right, and then root. So you can see here, this line will comes to the last. This line, the right of tree of data will comes to the last. That's a post order. Left, right, and then root node, and then root node. So you can see here the same steps. So now, at first left. So here, A of left is this. And then, once again, does B have left child? Yes. So once again, this function we got. Does D have a left child? Yes. Okay. So for does G have a left child? No. Does G have a right side? No. At last, root node. G is the root node. So G comes in the output side. So then, left side of D is completed. Then right side of D. Right side of D is H and L. H and L. So does H have the left child? No. H doesn't have any left child. Okay, so the poster remains what? Left, right, and then root. So left is no for H, and then right of H is L, L, and then root. So the root of L is H, H. So right side of D is completed. Right side of D is completed. At last D is remaining. So D. So left side of B is completed. Once left side of B is completed, then right side of B. That's an E. Does E have a left child? No. Does E have right child? No. Then root E. E comes in the output side. So then B left child is over, B right child is over. Only root node is left. That's a B. And then left child of A is fully completed. Then I'll go for the right side of A. So in the right side of A. The right side of A, does C have any left child? No. So it goes to right side of C. In the right side of C, we have the subtree. Does F have a left child? Yes. Does I have the left child? No. Does I have the right child? No. So I is the root node. So I comes in the output side. So left child of F is completed. It goes to right side of F. J and K. Does J have the left child? Yes. K. Does K have the left child? No. Does K have the right child? No. Then at last root node K. So left child of J is completed. Right side of J null. Then at last root node. At last root node is called J. So right side of F is fully completed. Once right side is completed, then is a root node. That's a F. So then for C, the right side is fully completed. Next is root node, that is called C. Then right side of A is fully completed. Next is root node, that is called A. This is the post order traversal. This is called post order traversal. So in the in order, left, root, right. In pre order, root, left, right. In post order, left, right, and root. This is how you can do the traversal in the trees. Okay, thank you.